Ham at NCAR, Matt Rockland at Anaconda, and the rest of the Pangeo team. My identification's down there in the bottom right, including my little, we're still looking for a little tree, a baby tree. Okay, so I don't think I need to, well, this slide, you know, hundreds of petabytes of data, hundreds of petabytes of, like even in the CMIP archives alone, we're clearly not going to download it. We all know this. And so the Pangeo project was developed. It's an EarthCube project, and it just finished, I guess, about the first year. And so they are trying to build a system that makes it possible for researchers to go and do computing next to the resources, scalable computing, interactive scalable computing on the cloud, also on HPC. But I'll focus on the cloud part here. So over on the left, obviously you have distributed storage, and it's using the Python ecosystem. So it's using Dask to do the parallelization and Xarray for the NetCDF data model. And then the user interacts with Jupyter. So you fire up the Jupyter server on the cloud, and they access it, you know, from their web browser. And here's a happy user sitting in the park on the Chromebook with a cell phone connection, crunching terabytes of data. Okay, so John, let's see. So John and I were kind of looking at HSDS together, and I went to a meeting in Tuscaloosa at the end of last year at the National Water Center, and heard about this National Water Model effort, and they were producing like 15 terabytes of data a month, and they were pushing that data as part of the NOAA Big Data Project onto the cloud, onto the AWS cloud. And then John and I went to the ESIP meeting in the winter meeting and found out about this Pangeo project. So we wrote a little proposal to get some cloud resources. John just showed you running on those resources, and there's a Pangeo instance now running on AWS. And so we got some free credits from Amazon to basically put Pangeo on AWS for the purpose of analyzing the National Water Model. So that's just a little background. And as you know, I guess as has been discussed, the problem is if you just take obviously that data that's been parked out there on S3 as part of the Open Data Project, and you try to access them as they are, a bunch of NetCDF files sitting on S3, and you do it sort of by the, you know, the simplest way, you fuse mount that and try to access that. You open up a data set and you look at a variable, and here I'm looking at temperature, 23 gigabytes, and I take the mean with Dask on 25 processors, and it goes off and it comes back in 2 minutes. That's actually not counting the 5 minutes it took to open up those files and read all the metadata. So, but this is kind of a fair comparison. I think it took a while. So even if we put the metadata all in one piece, and using this method, it would take 2 minutes. And if we use one of these newer approaches, in this case, if we're using Zarr, cloud-friendly format, which we'll talk about in a second, we take the mean, it finishes with the same number of processors in 11 seconds, 12 seconds. So Matthew Rockland, part of the Pangeo team, has a really nice blog post about HDF in the cloud and the different approaches, and he talks about cloud optimized geotiff, what that community did for 2D data essentially, and then what were the options we have for trying to come up with something for 3D data. And John just talked about some, and so so there's HDF plus Fuse, like I just showed you, it doesn't work too well. HDF with a custom reader, build a distributed service. John just talked about that. And then these new formats for scientific data. So, and John talked about some of the, hazards with coming up with a new format, but people have done it anyway. So, so let's talk about the Zarr format. So, the Zarr people, it's not like they didn't know about NetCDF, HDF. They obviously did, and they wanted to build something that was simple, that would sort of take this sort of sharded approach. It's a very clear, simple format. It's very well, nicely documented. The spec is laid out very nicely. Each chunk it's actually almost identical, I think, to HSDS actually in its design. So each chunk is in a separate object. The metadata is stored in JSON. The filtering is, the compression is done with BLOS. And important for the community, for somebody like me who's a domain, an oceanographer, it has Xarray, it has support with Xarray, so I can just do Xarray read and it looks like NetCDF. So, well, I guess, so we've been, I guess John just basically described this, there's, in Zarr, there's chunks, each chunk has like a name like, 0.0, the keys. And so any kind of key value storage mechanism can actually kind of store this. And what it actually looks like, if you, like this is just one of my numerical model outputs, from the AdCirc surge model. And if I drop down to the zeta variable, the sea surface height, and I look at, there's just two little, in addition to all those files, the 0.0, 0.1 and all those files, there's a little, this is storing on disk, on local disk. There's a .z array and a .z attrs. So the .z array is just the metadata for the array, and it tells you what kind of compression was used there. You see on the left, and you know what the shape is, and so on, and what the chunk size is. And then over on the right is just the sort of what you'd call, what I would think of as the NetCDF, you know, the metadata, the simple metadata, global, or in this case variable metadata. And it, you know, contains things that you notice from CF, like coordinates and, you know, units and stuff. But it also contains this array dimensions, which is there for NetCDF. And so the way it's been implemented so far, Zarr was written for HDF. But so you could think of these as being like the NetCDF conventions for Zarr to put this into the attribute information. So with all these things, actually, I just want to put this in there. It's interesting to look at, you know, if you have a certain type of data that you work with a lot, it's good to actually try out these different compression schemes. And in this case, Alistair was looking at his genomics. Oh, so Alistair was is a malaria researcher who kind of started this the Zarr project, and he's got DNA, and one got like 1 million in the columns, and mosquitoes like thousands in the rows, and then you know, and then 2 deep for the 2 pairs, and so for the pair. And then so anyway, he's got a certain type of data, and he can look at these different patterns and find out that, you know, in the upper right there, he's getting phenomenal speed with 15 time, you know, 18 time compression. But if he's working on maybe a slower file system or something, or, you know, some slower storage, maybe he wants to go down, you know, to the middle there and get higher, you get 30 times compression with slightly slower speeds, things like that. But I just want to put that up there because whatever, if you have a lot of some kind of data, it probably pays off to look at this kind of stuff. So so there's Zarr, and then there's like 3 other ones that sort of all did the same thing. There's N5, which also came out of the genomics community. It's almost identical in the approach. And so part of the difference is that so N5 has a Java interface, and Zarr currently only has a Python interface. And then there's somebody wrote a library Z5, which is C++ that reads both Zarr and N5, so that tells you kind of how similar they are. And then there's TileDB, and it was developed by Intel and MIT. It has its sort of distinction is that it has a sparse array model as well as just a dense array model. But it's now it was originally developed by Intel and MIT, and now it's being developed by TileDB Incorporated. So, but currently so the Pangeo team is interested in looking at all of these and also looking at HSDS. In fact, there's a storage benchmarks repo that they have that John has been active on, and some other folks are hopefully going to get more active on this sooner. It would be easier, of course, if we had the open and X array. So maybe that will happen also soon. So one thing I think what is really a good sign, I guess, is that encouraging is that Zarr is really community driven. If you look at the web page, you can see these acknowledgments. There's some heavy hitters on this list, and they're all participating in the discussion of how to add new features and, you know, the way this project should go. So that's a really good thing. So challenges, you know, I think we're still in this kind of evaluation phase of what will emerge, you know, as a community. I think the Pangeo team is actively reaching out, even though they're sort of met ocean, hydro kind of based. They're kind of trying to reach out to the astronomy community and to the genomics community, and see if we could kind of come up with, you know, if one of these sort of approaches would work, you know, for the whole community, so we don't have 5 things that are, you know, basically the same. Obviously, we need bindings for these different languages. These are coming. Like I know that Unidata is currently doing some work on a backend to the NetCDF C library to provide Zarr support. You they've just started that effort, so that's not coming anytime soon, I don't think, right, Ethan? And of course, as John said, we have there's a lot of investment in the current formats. Although all of these support the same workflows, which is kind of what makes it, at least a large percentage of the workflows. Like my workflows are totally supported, and I'm very happy opening up a data set that looks like NetCDF and just continuing to work that way. And then, of course, just in general, the cost of the cloud relative to, there's still the balance. This doesn't have anything to do with different formats, but a lot of people are like, well, I can't put my data in the cloud because it's too expensive. Because it looks like it's 10 times more expensive, say, than storing the data locally. But we've talked about all the benefits and all the things you get when it is on the cloud. And you don't have to store it in 10 different places. It's already stored for you in a bunch of different places. It's super reliable. You can share it. You don't even need like maybe some of these services, because you can just go to that URL and start subsetting the data effectively. So that's it. Oh yeah, so if you want to get involved with this, just you can actually go, just like John just said, you can actually go to the upper right webpage if you want to play around with Pangeo. It's a totally open right now Jupyter framework, Jupyter Hub with Pangeo installed, so you can try out some of these tests and crunch some massive data sets. And on the left is the website, and it's where a lot of great discussion is going on there about all these kind of issues. So if you're interested in this stuff, I encourage you to participate. It's a very open, welcoming environment. So I think that's it. Thanks.